Hello everyone. Um, Today is our very first day, for this Java training. So I would like to give you guys an overview on the Java full stack, uh, the development, right? In the sense, before we deep dive into various topics and concepts, which is laid across the Java platform, it's very, very important to understand to become a successful Java full stack developer. What is that I need to focus on, right? Because there are various technologies out there, uh, pretty much, more than 100, I would say. As a Java developer, what is that I need to focus on, right? So that becomes a very important question, right? We need to ask ourselves. So before, of course, this entire training program is practically kickstarted, I would definitely, like to explain you guys a big picture of what is that we are looking forward, right? So that's what is, this very, I would say very quick session is going to be, right? So once everyone is clear with what is this platform, how these technologies in this platform is really categorized, and probably in each category, what is that I need to focus on. So technically speaking, I think at the end of this session, by the end of this session, we would have drawn a line of a boundary, or I would say we would have defined a scope of our the training, or I would say the scope of learning for an aspiring Java developer. So that's going to be the objective. All right. So as far as your questions and doubts are concerned, I'll probably take it at the end, so that yeah, in that way, uh, I can anyways share with you guys my thought process initially. All right, fine guys, so let's get started here. So the very very first thing you need to understand from Oracle, who is actually owning the Java language and the Java platform, we actually have different Java editions, right? So if you really look into that, you have Java SE, you have Java EE, and then you have Java ME, Java Standard Edition, Java Enterprise Edition, and as well as Java Micro Edition, right? So the third one is basically kind of out of scope for us here, because we as Java developers or a Java full stack developer, we definitely want to focus on the Java web application development. So keeping that in our mind, the Java Micro Edition, it's basically for mobile application development, right? So for now, we will park it aside. But as far as your Java SE is concerned, it is basically for the desktop and Java GUI applications development. And then the second one is very, very important, which is actually Java Enterprise Edition, right? Which is basically for your web applications, for your enterprise business application development and whatnot. I think most of the interesting and advanced technology stacks, they are actually with Java EE. Okay, but just to remind you, in order to understand these Java EE technologies better, as an individual, I must be skilled very well with Java SE concepts, which is nothing but, technically speaking, a core Java. Not normally, anyone who starts with the Java learning, they get into something called as initially core Java, right? So that entire core Java is nothing but, it's Java SE edition. So I must be really hands-on. I must be really understanding most of the Java SE concepts, because at the end of the day, all your business logics, what you implement for these web applications or enterprise applications, they are actually focusing on writing the piece of code using only core Java. All right, that's how it is. So yeah, there we go about Java editions. And now, as far as your Java full stack development is concerned, let's start. What are all those verticals? I would say the various verticals wherein I need to be an expert, right? So first thing is I need to be very comfortable with backend technologies, and then the UI technologies, okay? And then I have DevOps implementation, and then I need to be very much hands-on with uh, cloud platform, or I would say cloud integration skills, right? So what are the different technologies, which we have in the back end, the Java UI and things like that? We'll probably take up one by one, right? So more or less, whatever, you guys are going to learn as part of Java SE, which I mentioned earlier as core Java, that definitely falls under, Java backend, right? No doubt about that. But core Java is not just the skill you need, or this is not everything to become a Java developer. Even if you really want to focus on pure backend development, core Java is not, not just the thing, right? There are a number of technologies associated apart from this core Java in the backend vertical. Now, what are those? Interestingly, you need to really, start with, okay, now I'm good with core Java. What next? So the next concept is definitely seeing how these small scale, Java applications can really interact with database. Maybe I have to start with my very basic of understanding, okay, how can I make a database connection? If I'm writing a Java program, right? It all starts from that. Next, I have to understand the client server interaction, in the sense, if I start writing distributed architecture applications, for example, focusing on the client server implementation, again you have number of technologies right there, but very quickly to understand a communication between a client and server program, maybe on a TCP/IP protocol, right? I would then talk about basically socket programming, okay, which is also called as networking, right? Java networking. Yeah, it's actually called as Java networking, right? So here, obviously, you have server sockets, server socket. I mean, in terms of API, again, that's okay. And then you also have something called as socket. All right. So that's your concept, which you focus on. Otherwise, if you're really talking about the Java distribution, distributed programming, right? If this is what you're talking about, then you have actually various things. Just to remind you, you have something called as socket programming. You have something called RMI, that is remote method invocation, and then comes various other distributed technologies. But I actually want to segregate them, and I want to put them in a different category called as web technologies. Okay. Now, this is where in the web technologies, you would actually start exploring something on servlets. And then, you definitely need to understand the JSPs, the Java server pages. Of course, there's a difference between these two, right? So servlets was the very first technology on the Java web application development as a server-side programming, where it started accepting HTTP requests on the web applications from the browser, process it, and started giving dynamic responses back to the browser, right? That's basically the definition of a servlet. But in realistical scenario, for any production-based application development, we can't really use servlet for everything, though it is capable of processing HTTP request. We cannot just use that. Why? Because the coding in servlets, it comes with its own complexities and challenges. Technically speaking, the way I start really creating my dynamic web page in the servlet, I have to start embedding HTML into the Java code, and that's when I can really incorporate all my HTML tags, like be it any kind of HTML tag, like div tag, h3, header tags, or font, or any styling, anything and everything I do for the UI side. All those tags are complexly involved within the Java code, and that's very difficult to code. That's where we have the next level of technology, which basically eases, your coding, and that's when we get into something called as the JSPs, Java Server Pages, right? So in JSP, then we have a pure segregation between the piece of code what a Java developer writes and the piece of code which is basically that entire web page creation. It means we are now going to segregate between your presentation layer and the business layer. It's purely a segregation. All right. So when these two layers are segregated, it's very easy to code now. So probably you can imagine at the same time, two developers are working on the same JSP now in a team. One is a UI developer who is focusing on tweaking and modifying HTML portion of code for the same JSP. And at the same time, you have a Java developer who is now working on the same page, but he is purely focusing on the Java part of coding, that is the backend business logic, right? So that becomes JSP, right? Other than these two, which are basic requirements for getting onto Java web technologies, right? You need to understand invariably you will start becoming part of, using other technologies here, right? You have HTML5, you have CSS4, you have JavaScript, right? And then you have jQuery, right? At least, if you really look into your basics of actual UI, it actually falls under the category of the basic Java web technologies. Okay. So I think with this, I would also like to add Bootstrap CSS. Okay. Perfect. So that's nothing but my basic technologies. And try to understand, guys, when I segregate these as web technologies, not necessarily these are the only technologies. For example, back in here, I was saying soon after core Java, you will get onto JDBC, right? You definitely need to use the database concept with your web technologies, right? Of course, we will see, what are the other technology stacks for interacting with the database. I mean, going further, we will definitely list out on ORM and all that. But to start with, basically your web technologies must be backed up by the support of JDBC as well. That is something which you need to understand. All right. And what else? Yeah, at the very starting of my discussion, I was mentioning that you guys need to be very much hands-on with core Java. What's the reason? So even in your servlet, when you're writing your Java code, even in your JSP, when you're writing Java code, understand one thing, that Java code, wherever it appears, at the end of the day, it's all nothing but a core Java concept. And that's the reason what I'm saying is you need to be very much hands-on with core Java. All right. I may have to repeat that point, going further in the next few minutes. But yeah, because it may be necessary over there. All right, that's my basic web technologies. Next is you definitely have something called frameworks, right? In terms of frameworks, the very first thing is you'll have to start with your database related frameworks. For example, conceptually, they are actually segregated as ORM frameworks, right? Again, with ORM framework, you have number of technologies. You have, to start with, actually, you actually have from Sun Microsystems or Oracle, it's called as JPA. And that JPA is now having number of implementations, and one of them is Hibernate. You have iBatis, right? You have MyBatis and things like that, right? The list goes on, guys. So again, there are number of ORM implementations from most of the open source communities, from product development companies and third-party vendors, right? There are so many things, but very importantly, as a Java full stack developer, even if you're focusing on initial two, what I'm listing down here as part of ORM, awesome. That's more than enough. All right. That's again, this is how we are trying to define a scope of our learning. Which again, which basically makes you becoming a successful Java developer, right? The Java full stack developer. All right. So that's that in terms of ORM. Next is you have, I would say, MVC frameworks, right? When you talk about frameworks, yeah, you have MVC, next one, right? So what MVC frameworks do you have? Very importantly, you must understand something called as structs to start with, right? So I really don't recommend getting onto Spring MVC when you get onto MVC. No, you don't have to. You have to first have kind of a background on any other MVC framework as to how does that framework work, how do you configure the controllers and actions and weaves and blah blah blah. You have to come from that kind of a background, and then you get onto Spring MVC. things will really start becoming very much easier. All right. So then you definitely can get on to Spring MVC. But before, so between your struts and Spring MVC, I can recommend you guys few more technologies. One is JSF, which is Java Server Faces, and one more, though it may look little I would say off the track from our training, I think it is still important to understand Oracle ADF. It may not be probably fitting 100% right in your technology stacks, but again at the same time you can't really ignore it. All right, because the agenda of using Oracle ADF is entirely different than when you have other business requirements for using other frameworks. Okay, I mean there are certain designated business use cases for which industry leaders, they definitely use Oracle ADF. All right, but yes, I definitely recommend and I love to teach you guys Oracle ADF. So what I mean is, so before you actually get onto the industry standard framework called Spring MVC, before that, if you really have hands-on with these three frameworks, then the fourth one, the Spring MVC, becomes cakewalk. As simple as that. All right, excellent. So once you have very much hands-on with these four technologies, right, that's really going to be awesome. All right, so pretty much I would say, yeah, these are the web technologies, right, which I have listed down. Again, what do you have? Yes, you definitely have other things, boss. Okay, you have something called as message brokers. Okay, very important. When I say message brokers, I'm really talking about JMS, Java Messaging Service. So there are a lot of messaging integrations or notifications. I think technically it's also called as, in terms of architecture, we actually design it saying, okay, what sort of notification layer do you have, and things like that. So the terminology is notification, right? So for the notifications or for the messaging, right, you definitely have again number of message brokers, but very importantly, you need to have very good background with ActiveMQ, RabbitMQ, and the topmost leader in JMS right now is definitely Kafka. Okay, Kafka is one of the most widely used and widely popular message broker and a streaming technology in the industry. All right. Yeah, so that's the tech stack which is required for Java messaging service. All right, guys. So what else? Yeah, you have distributed programming, web technologies, frameworks, wherein you have ORM and MVC, and then you have message brokers, right? But in general, before even, for example, let's say you're done with learning ORM, and actually, between your ORM and MVC, or probably let's say you're done with your ORM learning and now you started with MVC, where you have struts 2.x and JSF and Oracle ADF. Probably before you actually start with Spring MVC here, I would definitely recommend another framework, which is actually nothing but Spring framework itself. Okay, I mean, I could really say it as, okay, core integration framework. Yeah, let me segregate like that, and you definitely talk about Spring framework. So you need to get onto Spring framework, understand the core architecture of Spring framework, and of course Spring MVC is nothing but just one of the module within the Spring framework. You need to understand. Okay, by the way, Spring, instead of calling it as a framework, it is always better to call it as a Spring platform. Why am I saying like that? Probably you'll understand it in the next few minutes. All right. Okay, so that's your core integration framework. All right, so you start with this and then you go to Spring MVC. But here's the thing, guys. When you really start talking about the Spring framework, you have number of things to, I would say, understand, learn and understand. What are those? Or exploring, right? Because Spring is a very huge framework. So you definitely start with Spring Core. Okay, no problem. And then you have definitely, as I said, Spring MVC, which I already listed down here. So I don't want to repeat it over here. That's fine. I'll just skip that. But otherwise, you have other modules, guys. You have Spring JDBC. You have Spring Data JPA. You have Spring AOP, right? You have Spring Transactions. You have, I would say Spring ORM. Okay. You have Spring JMS. You have very, very, very importantly Spring Security. Okay. Never ever forget to get onto the depth of this module, guys, because the more and more you understand Spring Security, you will be in a very much better position to talk about security, to talk about security threats, to talk about various mechanisms and concepts given by Spring Security, which is very powerful in getting integrated with probably any security implementation industry wide. Okay, it is that capable. All right. So the original agenda of Spring Framework is, it is one of the highly sophisticated integration framework. Okay, Spring always helps you integrate with other technologies, integrate with other business applications. That's the strength of the Spring Framework. Okay, so if you really ask me, it doesn't really come up with its own tool. It doesn't really have its own UI. It doesn't really have its own predefined process or steps. Only one thing what Spring Framework expects from you is, whatever business application you write, whatever technology you use, make sure you are purely implementing your stuff with object-oriented methodologies and object-oriented concepts. That's all it expects. As long as you guys are adhering to object oriented methodologies and certain industry level design patterns, that's what is needed for Spring Framework to integrate with your application. That's all it is. It is very simple. Maybe whatever I'm telling you right now, you may not be able to understand as on today, because you guys are just starting, you're just putting your very first step, into the Java platform. Certain things may be confusing. That's okay. But I'm just telling you, you need to just follow the object-oriented methodologies and design pattern approaches in your coding. And that's the only way Spring Framework can really integrate with your application. It's as simple as that. Okay, and that's why Spring Framework is much more flexible than any other framework, because other frameworks, they already have predefined steps. They already have a predefined I would say standards and procedures, right? They come with their, I would say, an inbuilt boundary specific APIs and things like that. But in that matter, Spring, goes far away in the sense, it takes a very interesting leap altogether. All right. So yeah, we will anyways, when we get onto Spring Framework, probably I'll start really expanding all these things what I'm trying to mention today, as a first day. All right. So that's not it, guys. Very, very, very important. You definitely have Spring Boot, okay, which is again one of the most interesting and one of the most, widely used platform, or I would say a framework these days. Okay, so Spring Boot, right? Uh, with the core Spring framework, if you guys can do all these things, pretty much all these things can be again implemented by Spring Boot. Why? Because Spring Boot is not just initially, probably when the Spring Boot was released as an initial version, as I think 1.0 or something, it was kind of a module out of a Spring framework. But later on, it really started dominating in the industry. And as on today, Spring Boot is again a different platform altogether. Though it is still coming out of Spring framework, it is now termed as, it's an independent platform. Why? Because whatever you guys can do with the Spring framework and technologies, the same thing can also be done with Spring Boot alone. All right, again with the help of all these modules. It means, what I'm saying is, uh, the amount of complexity or the amount of boilerplate code and configuration what you do with these things, it will drastically reduce, maybe sometimes more than 50% when you get onto Spring Boot. You don't have to do so many things, and you can directly start focusing on your business logic. And that's what I think that was the original intention behind Spring Boot, by the way. All right. So one of the main purpose of Spring Boot initially, when it was introduced, was to create REST APIs. But later on, you need to understand it really started contributing a lot in implementing something called as microservices. Okay. So whenever we talk about creating microservices for our business applications, 99.9% we are actually depending on Spring Boot framework. I mean, that's the industry standard right now. All right. So anyway, now as we talk about that, I think I segregate microservice as another category so that we can really talk much more about that. All right. So anyway, so this is your then core integration framework, right? And did I forget anything? Yes, you can definitely add.
I didn't get that.
Spring time leaf. Sorry guys, my Siri, the voice command tool was activated for a second. Okay, sorry for that, guys. Yeah, so then you have spring time leaf. Yeah, by the way, you have spring time leaf, and then what else? Spring transaction, JMS security, Spring Soap, by the way. Yeah, you have actually soap-based web services, and Spring can really get along with Spring Soap. All right. And what else? Yeah, I think pretty much these are the things from Spring framework. Not to forget, of course, you have something called as Spring Cloud. Okay, I'm just listing down here, but probably some of these things will repeat in your microservices categorization. That's okay. We'll do that. So now, in terms of again the frameworks, I think we should be good here. That message brokers, we are good here. Then I'll come back to microservices. Okay, when you say microservices, you definitely work with Spring Boot a lot, and you work with Spring Cloud, and then you work with Spring JMS. So in a nutshell, your microservice will expose APIs. Your microservice will be having the cloud integration along with the notifications architecture. That's exactly what I'm trying to represent here. Okay. Yeah. So very quickly, just to tell you guys, if some of you are not understanding what is microservices, see, all this while, in the sense, at least until 2013, we all used to have the whole production-based application as a monolithic application. Okay. Now, there were so many complexities with the monolithic application development and deployment. For example, the whole application has a lot of modules, and even though I'm just working on one module at the sprint, but when I give my sprint release, I have to redeploy the whole application. And again, the QA guys, they have to do the regression testing for the whole application. Why? Because who knows, while I address certain new features as part of one module, what's a guarantee that as a developer I did not really break on any other things which were basically working functionalities. Sometimes they may be connected to other modules itself, right? Because there are a lot of places where you have written your common coding, you have common configuration, which is shared by so many components of your business application, right? So that is one thing. Second thing is I had to redeploy the whole application, and so whatever I do with my application, it was with the scale of complete application, the whole, right? It's not just a part, right? So that's these are some of the challenges, and that's where industry started moving towards something called, okay, instead of having 5 different complex components as part of one application, can I really segregate, can I isolate these components or features from the application, and can I really start developing and deploying them as individual components? That makes more sense, right? So you divide your single application into number of applications, and now technically they all become very lightweight components. Why? Because each and every module, you just go and pick up that particular project, and that's your module. So it is nowhere probably related to the coding and configuration of other module, because every module for you now, it's a single application. So that's where this isolation, what it brought to the application development, these small isolations or pieces, of your application, they are technically started becoming microservices. Micro means small, service means it's a functionality, it's a feature, it's a component, it's a module, right? It can be anything. So sometimes your microservice, it could represent a whole module, or sometimes it is very complex, and you may have one single module out there which may probably have a number of microservices. Why? Because the decision which you take, as to how can I really migrate my monolithic to a microservice, it all depends on the existing complexity with which your monolithic application is existing. If it is too complex, there's so many modules and each module is looking like a whole new platform, then obviously, each module will have a number of microservices. And at the end of the day, what are these microservices comprising of? They are comprising of REST APIs. Again, not necessary. I definitely would like to put a star mark there. Not necessary. Microservice means always REST APIs. You will definitely have, or you may have, microservices with SOAP services as well. Because microservices is an engineering concept of isolating a monolithic application into various components, but not necessary it should be with REST API all the time. It can even be with SOAP services. All right. But yeah, in a nutshell, that's what I was trying to mention. This is the reason why we use these three technologies. Spring Boot is to create your REST APIs or SOAP APIs. Spring Cloud is basically to leverage and address certain challenges related to, okay, it's not just enough that, I have a very good technology called Spring Boot and I'll successfully develop and deploy my microservices. No, that's not the end of the world. Probably that's where your problems could start. It has its own challenges. So you have certain DevOps challenges. You have certain cloud integration challenges. You have certain infrastructure related challenges for your microservices. Then how do you address those questions? That's where you have Spring Cloud coming as an answer. Okay, you start looking towards Spring Cloud. Okay, hey Spring Cloud, what can you give me? I have these challenges in terms of my deployment, in terms of my load balancing, in terms of my I would say the routing or proxies and things like that. Do you have any solution? Yes, Spring Cloud can very well relate to your questions, and it already comes with a bunch of solutions there. That's again one more interesting technology stack. All right, I mean, just to give a glimpse, guys, Spring Cloud has something called Netflix. It purely uses Netflix OSS technology stack, and that's where you have a lot of things. You have Hystrix, you have Ribbon, you have Zool. There are a lot of things out there. Okay, I'm just trying to give you guys only the glimpse here. These are not the only things. There are a lot of interesting technologies out there as part of Netflix OSS, but I'm just trying to highlight the important ones as part of Spring Cloud. All right. Next, of course, as I mentioned earlier, Spring JMS is nothing but it easily integrates with your ActiveMQ, RabbitMQ, and Kafka. All right, that's that. And what else? Yeah, I think that reminds me one more module here. Basically, guys, try to understand. You have something called as Spring Web Flux, or I would probably also call it as reactive, applications, reactive architecture or reactive apps. Okay, I'll just leave it like this. Otherwise, I don't want to really confuse you guys more. So these days, there is also something called as reactive based architecture or reactive applications. Okay, so any application or any microservice you want to convert it into a reactive application, then it comes with certain set of properties. Just to give you a glimpse, guys, if you want to call your application as reactive, then it should have certain properties. For example, it should have isolation, it should be message driven. Okay, it should be scalable and things like that. So once you have these properties as part of your application, that is when you can collectively call it as, okay, my application is now reactive architecture based application. But it must and necessarily have all these properties implemented, and each of these properties, we are talking about set of technologies. Okay, isolation, yes, there are some technologies. Message driven, yes, it's a JMS. Scalability, yes, you have certain technologies to implement it. Responsiveness, again, you have certain, technologies to implement it. Okay, maybe on the very first day today, you may not be able to understand, again, what I'm talking about, all these points over here, but I'm sure it will definitely be a stepping stone to understand, okay, what is that I'm getting into, for starting from today, for becoming a successful Java developer again. All right, the Java full stack developer. Okay. All right, guys. So that's that. And yeah, let's talk about Java UI. So I think in terms of Java basic web technology stack, I think we already listed on certain technologies out there. So I don't want to really repeat that. But other than that, what you definitely need to know is AngularJS. Okay. When I say AngularJS, I'm talking about 1.x. Okay. It's necessary to know it, and then you can study something on Angular 2 or 4. I think even one of the two, if you know, that will be very nice. And you need to know a little bit of Node.js. The reason is you definitely need to have, again, at least an idea on a small scale as to, okay, as a Java developer, do I really understand mean stack, MEAN, MongoDB, Express, Angular, Node.js? You must have an understanding on this. And I definitely, don't push on getting onto React.js, at least for Java developers, because very rarely there is gonna be a requirement for a Java developer to really work on React.js. But yeah, if you come from a little background of React.js earlier, or you have a lot of interest towards learning React.js, even though you guys are going to be Java full stack developer, yeah, it's fine. You can still get onto React.js and get to know certain things over there. Otherwise, I really don't want to push on that. Okay. Next is, yeah, once your code is developed and designed and developed using all these technologies, then how do I deploy? How do I keep continuously deploying? And that's where exactly you get onto something called as CI/CD, guys. CI/CD, continuous integration and delivery, right? And the answer lies with certain tools for CI/CD, and very importantly, it is Jenkins. I mean, you have other tools, for example, depending on the technology stack you're choosing, you have different platforms. For example, even for the CI/CD, you have something called cruise control. Okay. But yeah, I think the most widely used tool is Jenkins. Yes, it makes more sense to have hands-on with Jenkins tool, rather than any other tool. All right. So yeah, next is you have version control systems, right? Again, you have number of tools out there, right? It's not only Git or GitHub, by the way, guys. Please understand, this is not everything. You do have certain, tools which are existing from decades together now. You have CVS, SVN, VSS, Perforce. There are so many tools, guys. Don't think that whenever we talk about version control, it's only GitHub or Git. No, it's not like that. Maybe it is Git or GitHub is very recent one, which is cloud based. But I come from a background, especially where we had all these other tools, and we did not have Git at all. So that's the very latest invention. All right. So that's related to your so the understanding the process of automating your continuous integration and delivery is nothing but getting onto your DevOps. And you have, again, see, you have verticals within DevOps itself. There are so many components you need to know as part of DevOps. One is CI/CD, one is version control, one more is orchestration, where you definitely then get onto Docker. I mean, I don't really, again, force on Kubernetes, but yeah, it will be good to have basics on Kubernetes. Okay, that's how it is. So that becomes, part of orchestration. All right. So for a Java developer, in terms of DevOps vertical, he or she must be comfortable with three different verticals within DevOps. One is CI/CD, one is version control, and one is orchestration. And you definitely, get to see how these orchestration technologies, whether it is Docker or Kubernetes, how these can leverage working with microservices. So whatever microservices you guys develop using Spring Boot and other technologies, okay, can I spin up a container and then deploy? Perfect. That's exactly what you need to go, you need to understand, and you will be understanding. And then technologically speaking, so Docker will not only communicate with microservices, it will spin up a container of microservices, and that entire process can be automated using your CI/CD tool. So what am I saying here? I'm saying that your Jenkins can take a source code from a version control, it can build, it can package, it can deploy that particular microservice as a Docker container. That's what I'm mentioning. So the whole thing has to be automated, and that's going to be really interesting. Okay. And the last but not the least vertical, you guys must be comfortable, is the cloud platform, where you have definitely, number of cloud platforms over there. But very importantly, you need to be at least familiarized with two different platforms, AWS and GCP. You do have Microsoft Azure, and of course, you have, you can still develop, deploy and maintain your applications, Java applications on Microsoft Azure. I'm not saying no, but the probability of having these Java applications on AWS or GCP is more when you compare to Microsoft Azure. And that's where I want you guys to be hands-on with, again, AWS and GCP both. So again, when you say AWS, there are a number of technologies out there, So whenever anyone is talking about Amazon Web Services, it's not just about, EC2 or S3 or RDS, that's not the end of the world again in AWS, right? Probably before even EC2, you have to really start understanding, AWS with actually IAM, right? And then yes, you can get on to EC2, and then you need to get on to Elastic Load Balancer, then you need to get on to Elastic Beanstalk, okay? And then you have S3, then you have RDS, and then you have SNS, you have SQS, and then you have OpsWorks, okay? And what else? You have basically CloudWatch, okay? You have something called CloudFormation. Perfect. And that's not it. Again, the list goes on and on, guys. You basically have there are a few more things actually. Yes, ECS, okay, Elastic Container Services. All right. And what else is very important technology? I'm just trying to think of that. Yeah, you have the NoSQL implementation, right, which is DynamoDB basically. In the mean stack, if you're saying you're exploring on MongoDB, then here on AWS, you need to know DynamoDB, okay? And what else is required? Yeah, at least, these technologies on the AWS, you guys must be really, really hands-on, by the way, okay? That's what um, I'm going to stress upon saying, okay, not just the theoretical knowledge. Similarly, on GCP, you have similar kind of technologies for creating virtual machines, having load balancing and everything. Yeah, you have, again, technology stack on the GCP cloud. All right, guys. So yeah, I think all in all, I can definitely say that uh, these are the number of technologies you must be learning in order to become a competitive uh, developer or a competitive professional, to become a Java full stack developer. I hope this definitely gave you guys some ideas as to where to start, probably what to start with, and what is gonna be my overall objective of the entire training life cycle. Oh, okay, fine, these are the things I have to focus on. I'm sure at least some sort of plan you guys can come up with individually, right? So that's it, guys. uh, yeah, I think I can now take your questions, uh, if you really have, and I'm sure you must be having a lot of questions. Okay. Yeah, so let's take a short break, guys, and then I'll definitely take your questions. Let's take a 5 minutes break. So meanwhile, you can think of certain questions here now. All right. Thanks, guys. We'll again talk soon. Thank you.